Hi. Over the next few minutes, we're going to be talking about the idea of augmenting search based on location. And I know what you're thinking. The internet has made it so that location isn't really a problem anymore. And for the most part, you're right. When we're thinking about the idea of shopping, we don't necessarily think about location first. We might think about what site we're on or where the product is coming from in terms of vendor, but we kind of let the website obfuscate where we're getting our products from, albeit from the United States, from somewhere in North America, South America, Asia, or Europe. Sorry, Australia, I forgot about y'all. But there are still many places where the idea of location based results makes sense. One of those being the next time you order food. Trust me, you're going to be really upset if your pizza arrives in 2 to 4 shipping days. The other one is when you're in a place where sadly not a lot of people can reach you. You're going to want to know what's available around you and make it easier for you to make sure that you're not going to order something that is going to require a little bit extra work to receive. The other is where you're thinking of maybe living, visiting, attending school. Who knows? All of these things have their own benefits, and figuring out their proximity to either your current location or somewhere will make sense. So, we're going to be talking about the idea of search and location-based search. The search side of that is pretty simple, and obviously I work for Elastic, so I'm going to suggest Elasticsearch on this one. But the reason being for that is its ease of use, the fact that data is in a readable format, and it follows a policy of data storage that focuses on the 3 tenets, which is speed, scale, and relevance. You want your information fast, you want to be able to scale it up to your production level, and you want to make sure that you're returning results that are relevant. Now, we'll get into a little bit more about how you set that up later, but I do want to take some time to talk about the idea of relevance. Relevance can mean a lot of different things. Basically, relevance is the importance of the item to your search. How much are the factors in play versus just returning what seems to make sense? For instance, if I'm shopping for a product, I may want to see items that are going to arrive sooner over items that have a higher rating. And this is because I might need something very soon. But we're going to be talking about relevance based on proximity. And the way that we're going to do that is we're going to use geocoding. Now, for those that don't know, geocoding or a geocode is a set of graphical coordinates that correspond to a location. Basically, it's a set of numbers that pinpoint a single unique space on the globe. And you can use those numbers as general or specific as possible to pinpoint 2 places and their distances from each other. For instance, as the screen shows, while I can be in New York, my geocode at the Empire State Building is very different than my geocode at the Statue of Liberty. And I can use that to determine exactly how far as well. Don't worry, we're not going to be doing that much math here. But in terms of getting these geocodes into Elasticsearch, it's pretty simple. We have some type of document here, and our location data is set as that latitude and that longitude as a string. Furthermore, you could use floats, you could use an array of strings, an array of floats, you can use geopoints, or you could even use a hashed geocode known as a geohash. Elasticsearch will handle all of those. For this example, and as we'll see in our demo and in our further slides, we're going to be using it in this format. Two numbers highlighted as a string separated by a comma. So once we add this information into Elasticsearch, how do we get information within boundaries? I'm going to highlight two of them. We're only going to show a demo for one because it makes sense based on what we're presenting. The first one, the one that we won't talk about, is a boundary search. A boundary search basically says in our query, we want to make sure that we're creating entries or we're finding results that fit within a boundary. Think of a rectangle being drawn. And actually, when we do visualization of different places, that's what's happening, is we're creating a bounding box. And that bounding box could be something that says everything within the top left area to the bottom right area, and it'll only show items within that space. Now, this is a great idea when you have a very geometric position that you want to show results in, but unless you live in the state of Colorado, I don't think you're doing much based on the geometry of the space and more on the geography of it instead. So in that instance, we can use something called the geodistance. And the geodistance is really what we tend to see on websites and products. We can say, hey, I want something that is within a distance, within a set distance of a certain point. In this example, we say, I want something that is within 200 kilometers of this place. Now, I'm not entirely sure where this place is, but whatever we want needs to be within 200 kilometers of this place. And then we let Elasticsearch do the math and basically take all the results that we get and filter it based on that information. So the next step here is figuring out, how do we get the geocode from data? Now, if we're lucky, and I'm hoping that we're lucky, the data will just give us the geocode and we don't have to think about it too much. This is great. I love this. As you can see here, we're looking at a snippet of a data set from a college that we're going to pull from our demo. And you see right here and there, the geocode is set in 2 values at the end of this. However, if we're not lucky, we'll have to use an external service to look up the geocode based on a particular point. I'll give you a list at the end of this talk. We're going to be using one in particular, but it would be the same service that we would need to use if we were going to get our data from users. And speaking of, how do we do this? We're trying to create a service that gets one set of one location in comparison to another location. We need to check our data points, our geocodes, against something. So how do we get that? Well, the first one is with their permission. Most modern browsers come with the Navigator JavaScript geolocation API that allows us to ask the browser for its latitude and longitude. Now, it'll pull that information based on a bunch of different information, usually provided by the internet service provider, and it'll then give that information out. The problem with that is if you're using something like a VPN, that information could be wrong. Also, how accurate do we really need to be? I might get away with just saying, hey, I'm in San Diego, in comparison to trying to find things within my exact address. Now, in some instances, we do want to be as precise as possible, and this is a good option. But when we don't want to have to deal with that, what we can do is have them tell us where they're looking. And I really like this idea because it allows us to find information based on not their location. Now, this is good because if I'm looking for something on the other side of the country, maybe I'm about to move and I don't know the address, or I'm traveling, I don't need to know an exact location. I don't have to give you any information. I can just type the name of the city and have it, again, use one of those services to approximate a geocode that I can then find information based off of. And of course, the solution that you go with will depend on a lot of different factors. But for our factor in this example application that we're going to be building, where we look at the experience of a student getting ready to choose a college based on a bunch of different factors, we're going to just have them say, I'm looking for things in this area, and have them create a base geocode off of our search request. Now, for a couple of times, I've mentioned different services that you can use. The one that we're going to be talking about is the Google Maps API. Now, I don't have enough time to go into the process of creating a key, but basically what you're going to do is you're going to go into the Google Cloud console. You're going to create a new project. You're going to go to the Places API, and you're going to enable the API and create your API key. This is pretty simple, but it does have a few steps. You'll have to enable billing. You'll have to provide a credit card. Don't worry, in just this demo, I've never gone over the actual free tier that you can use. But we won't have time to talk about all of those different steps here. Instead, we'll talk about how we're going to use this process in our project. So the first thing that we're going to do is we're going to install the Google Maps module from PyPI. Simple, pip install. Next, we're going to create a client and provide it with that key that we got in the steps before. Then we're going to create a Places autocomplete query. Now, Places autocomplete is essentially that service that you use when you go to Google Maps and you start typing, and then it autocorrects and starts filling in suggestions based on what you've typed. The way that works on Google is very different from how we're going to use it. We're essentially going to have it send us some suggestions back, and then we'll filter it out and give you the best options that we think that you'll want. And we'll do that by filtering out the different types to just cities, as well as just the components, that being only entries that are in the United States, because we're going to be working with schools that are in the United States. Next, we're going to get those latitudes and longitudes based off of those results, and I'll show you what that looks like in the demo. And we'll apply that into our location and our query in Elasticsearch. From there, we can add any other tags that we want to also filter by. Then we can show, as the screen shows, all the results that are within 25 miles of the given latitude and longitude. So before we begin, I want to mention a few things. In this demo, we grabbed all of the different institutions post-high school from the Department of Education. This information had a lot of really cool pieces of data, like tuition rates and student loan debt medians and acceptance rates based on race, and a lot of other information. I can't guarantee its accuracy because this is what they reported to the Department of Education, but I hope that it shows that we can use the latitudes and longitudes that they provided with the locations that we provide and show people results in the areas that they're looking for and help them start to drill down into making better decisions on selecting a higher institution. Let's take a look. Okay, let's take a look at this. This is our application that is our college search website. Oops, should probably start the server. There we go. And we'll hit OK. So what we have here is the ability to search for colleges based on their location. Now, of course, I can go in here. I am from San Diego. So if I put in San Diego, it's going to say, hey, here are a bunch of results if I just search for San Diego. But did you mean San Diego, California, or San Diego, Texas? Now, if I say San Diego, California, it's actually going to show some different results because now what it's doing, it's searching based on this latitude and longitude, this geocode. So how do we get that geocode? Well, I'm glad you asked. Let's go over to the code and take a look. And if you want to see what's happening here, let's actually take a look and say the original search, what it did, we put in the query of San Diego and it said, hey, I know of some cities called San Diego. We have San Diego here in California, and here's the latitude and longitude for it. If we look over here, those latitude and longitudes will match. So how did we get from this to this? And the answer is we created this little function over here that when we create a search, the first thing that it's going to do is it's going to try to get cities by name. And this get cities by name basically takes the query that we passed in and it puts it in through the places autocomplete function in Google Maps. And from there, we'll say, hey, we're looking for any cities that you find that hit this query that are indeed cities and that the country of this location is in the US. And I think if we go in here, we'll see this country, US, it's there. I did have to look up the docs to figure out what it actually wanted there, but it's pretty simple and the docs are actually really well done. From there, what we're going to do is for each of these results, we're going to create a city object. And as long as that place is indeed a country in the US, I do believe every once in a while you get a little goofiness there. We'll do one more check to filter that out. Then we create the city class here. And this city class basically just converts this into something that's a little bit friendlier to work with. Instead of having to say city result name, city result address components, second index short name or long name, and that's where, again, that double check comes in. We actually go in and make sure that this information here tracks. Then we are able to go in and work with this instead of raw dictionary data that becomes kind of hard to follow along with. So once we have that city name, we take the location from it. And that is this location here. And we then send, if they click on it, we then send a different query that's built based on that location. So as you can see here, we have, this is the second, this is what happened when we clicked, yes, I did mean San Diego, California. We see, create this query with this geo distance 25 miles from this location, and that is the location of San Diego, California from its central point. And from there, we see that this was actually stored in the URL, which means that if we know the geocode, we could just apply it directly to the URL and get results. But the overall goal here is to just make sure it's really easy to find that city based on the search. And that is actually done in this function here, in this Flask function called, that's actually the wrong one. It is this one, search schools. And as you can see, we have a form that was that bar up here and the go button. And we say, you know, if there was a city, we apply it. We're trying not to work with the city if we don't have to. Instead, we'd rather work with a location. We have some other tags for future faceting, such as sorting or filtering by the state or tags that are provided. Those aren't implemented in this demo. But then we take all of that information and we build a query based on what we have. And again, when there is a location, we say the response is get schools. Here's all the information. Otherwise, get schools, and then this slightly less information. That then is put into this function here called get schools, where we build out our Elasticsearch query. We say, you know, let's start with the Boolean filter. And based on what data we've been given, we will add information, and we'll keep adding it and adding it and adding it. And then if there's a query, we'll include our query until finally we have our end result. And that's what we got here. Now, in our example, when you select the location, it removes the query. A lot of that is just for debugging and testing and to make this as simple as possible, and to also show that we're only showing results based on what we see here. Now, again, if I click on education here, what we should see is this will filter out down to just the items that have the education tag enabled. And we can see this here, our query changed, and it now includes the tag education in the terms. So it's only showing those results that fit that model. And just like that, we've built a project that allows us to search based on location. Now, obviously, this is nowhere near production ready, but I do want people to think about this before they start to roll out their next location-based application. For those building the next Uber or Lyft, remember, building things at scale could come at a cost. As I mentioned before, Google Maps and the Places API with it are not free. You get a certain amount of usage. I believe it's $200 a month for free. And in my testing, I never went over that amount. I never came close. But if you're building this at scale, you're going to want to put some things in place to make sure that you're not hitting the Places API every single request, especially when you have to run that request multiple times. This is where caching comes in. Cache some of those results, cache the most popular ones. Also, you may not even want to use Google Maps. I checked and double checked their terms of service. There's nothing wrong with me using it the way that I'm currently using it. I would just need to specify on the website somewhere, if it were public, that it was getting results from Google Maps. That said, if that's a problem, there are plenty of other services that you can use, and they each have their own different usage, API restrictions, and price tags. I would suggest, if you're going to play around with different options, check out GeoPy. GeoPy has a bunch of different configurations that you can use that allow you to hot swap different services and keep most of your code the same. I use Google Maps in this case because working with the API directly seemed easier to me at this point, and I wasn't really planning on picking and choosing. I knew I was going to use the Google Maps API the whole time. Also, if you are looking for based on where the call is coming from, be sure to take a look at that JavaScript Navigator geolocation method. It's pretty easy to use. And of course, it's going to make sure that you have permission to use that person's location before. If they say no, then you're going to need to program another way around it, in which I would look at the solution that I provided in the demo. Last but not least, anytime you're dealing with someone's location, you want to make sure you're doing it the right way. If you notice, we never store anybody's actual location. Sure, some of the URLs could be logged in Nginx records and things like that, but it is not tied to any individual ever. And that's because I want to make sure that even in my demos, I comply with my own personal ethics as well as government regulations. That said, I thank you for your time. I really enjoyed working on this project. On a personal note, I actually started this project because I have a younger sister who's a junior in high school, and she's starting to look at college options, and I wanted to help with that. And I was able to give her some options that she didn't consider in her search, but were based on locations that she wanted to be in, as well as some of the top programs and financial guidelines that would fit her budget without having to go into large amounts of student loan debt. So if you have a problem like this and you're wanting to figure out how you can implement location-based searching, I'm always available. You can reach me at KJAY on social media, mostly just Twitter or LinkedIn. But once again, thank you so much for your time, and I hope you have a great rest of the conference. Take care.